Hello everyone, today we're going to talk about Stepmotor controller SMSD-822. But firstly, please allow me to introduce the motor itself. It is a standard SM110201 motor, the biggest motor offered from our range, with a phase current of up to 8 amps. This motor is our alternative to NEMA 43 standard, with all the same sizes of the flange. SMSD-822 controller is intended for 2 or 4 phase stepper motors with an average current from 5.5 to 8 amps. SMSD-822 supports several different operation modes, and first of them is the manual mode. Manual mode provides us with stable control of direction and speed of rotation. In this mode, control is carried out by built-in buttons on the side of the controller or by externally connected buttons through special inputs. Second operational mode is the driver mode, where the controller is operated by pulse and direction signals. This mode is very popular with different kinds of CNC system where the control commands are sent from external controller or through a LPT port of a personal computer. In driver mode, controller can be operated via two-phase quadrature signal with a phase shift of 90 degrees. Such signal might be sent from an optical cell SIN. Any other optical encoder with a quadrature signal may be used as one of those cell SINs. Next comes the tracking mode. This mode gives possibility to control the position by internal or external potentiometer or by any analog signal from 0 to 5 volts. The shaft of the motor will be changing the position the same way you are changing the position of the used potentiometer. So if we move the potentiometer to the left from its center point, the shaft of the motor will turn left as well. Same goes if we turn the potentiometer to the right from the center, the shaft of the motor will go right. And of course, SMSD-822 can operate in controller mode. There are two possible options of operation in this mode. The so-called standalone mode, when the SMSD-822 is operated by a program preloaded to it via the USB interface. The second option for the controller mode is the direct control. It gives us an opportunity of sending commands directly from the computer to the SMSD-822 on the go via the USB interface. The supply voltage of SMSD-822 is neither from 110 to 220 volts of alternating current or from 70 to 200 volts of direct current. On the front panel we can see special inputs for connecting the power supply. The first input is for connecting ground. Please note that there is a special output for ground on the side of the controller that also needs to be connected. Then followed by two inputs for power supply directly, and there are four outputs for connecting the motor. Those outputs are marked from A to B, where A plus and B plus stand for the beginning of the phase and A minus and B minus stand for the end of the phase. There is also a D-sub input on the front panel for 25 pin. It looks very much like LPT port on old computers, but it is definitely not. Using this D-sub input, SMSD-822 can receive commands from other controllers as well as send commands itself to other controllers as well. The connection scheme of D-sub input is provided in the manual. On the side of the controller we can see the operating buttons. The very first of them is the start button. It executes the operation of the program. Next one is the home button. After pressing it, the motor will start rotating backwards until it receives a special signal from a sensor to a zero input located on the front panel. And of course the reset button. If anything goes wrong, you can always press the reset button and everything will stop immediately. And right over here we have a built-in potentiometer. In different operation modes, the built-in potentiometer acts differently. In manual mode, built-in potentiometer is used for speed control. In tracking mode, for example, this built-in potentiometer will be the one operating the position of the shaft. By turning it left to right, the shaft of the motor will also go left or right. Next, we have our 8 switches right over here. The very first 2 of them are responsible for operation mode of the controller. Switches number 3, 4 and 5 are responsible for the microstepping options. All the available microstepping options are printed in this chart right over here. Each step may be divided from 2 to up to 256 times. If we set microstepping option to half a step, then each rotation our motor is gonna be performing 200 steps, and so on. Switch number 6 is responsible for holding current. When turned on, it's gonna use 100% of holding current to hold the motor in place. When turned off, the controller is gonna use only 70% of current to hold the shaft. This is needed to save the motor from overheating and for minimizing power consumption. And switches number 7 and 8 are responsible for phase current and can be set from 5.5 to 8 amps depending on the type of motor we are using. Next, on the side of the controller, we have LED indicators to indicate the operational modes of the controller. They are followed by a USB Type-B input that is used for connecting the controller to the computer for further programming, or for using the controller in the direct control mode and sending commands directly from the computer via USB to the controller. In this case, the controller should stay connected all the time. On the bottom side of the controller, we have a fan mounted into the radiator. We recommend installing SMSD-822 sideways like this, so there would be enough space for cooling the radiator itself.